Offshore, the same principles apply, but they have to use specially designed seismic survey ships, built to withstand the rigors of this often hostile environment. The ships are equipped with water or air guns capable of firing shock waves down through the sea into the subsurface. As each shock wave travels down through the various rock formations, part of the wave is reflected back to the surface by each layer, while part of the wave continues through to the next rock layer, where a similar wave separation occurs. The seismic vessel tows lines of sensitive instruments called hydrophones, which pick up the reflected waves as they reach the surface. Variations in the density of the rock formations affect the travel time of the reflected waves. On board the ship, technicians use sophisticated equipment to record and measure the travel time of the reflections. By surveying a cross-section of an ocean area in this way, they accumulate data which, when analyzed and processed by computers, are digitally recorded on magnetic tape. In the seismic laboratory, the tapes are subjected to detailed analysis. Here, the expertise of the modern explorer is brought to bear on the data to produce seismic pictures of the rock strata miles beneath the seabed in the exploration area. Computers are used to process the data, from which geophysicists interpret and construct subsurface contour maps, which may reveal the distinctive geological features of a hydrocarbon trap. These pictures are, in a sense, treasure maps for geologists and geophysicists who use them to make predictions on the possible locations of gas fields. But again, there is no guarantee that their predictions are correct. The only way to determine whether gas is present is to drill an exploratory well, usually through the highest point of the underground structure. Because of the inevitably high risk nature of this enterprise, this is often called a wildcat well. A variety of drilling rigs are available to drilling engineers to match the different surface conditions they have to face at sea and on land. But they all have in common the task of drilling a borehole into the Earth's crust to locate any reservoirs of trapped gas. The most commonly used offshore drilling rig in shallow waters around Britain is the jack-up rig, so named because its supporting legs, which stand on the seabed, can be literally jacked up and the whole platform moved from one location to another. It's a self-contained island of steel, operated by crews known as tool pushers, drillers, roughnecks and roustabouts, whose job is to drill a hole of up to 25,000 feet deep. Most exploration wells are drilled vertically, but with production drilling it may be necessary to drill directional wells. As many as 20 wells may be drilled into the reservoir from one platform, thus tapping the field's full potential. These men may have the benefit of modern equipment and technology, but their task is still difficult and physically demanding. The weather can be terrible, and the North Sea, where many of them work, is notoriously rough. Ultimately, it is these men who directly experience the dramas, disappointments, and excitements of exploration. The basic technique of drilling is the same on all rigs, whether on sea or on land. Penetration is achieved by rotating a column of hollow steel pipes, which drive a powerful drilling bit grinding down through the layers. As the well deepens and the bit descends, it's necessary to connect additional lengths of drill pipes, which are constantly added at the top to form a drill string. The drill bit has to be changed regularly, so all the drill string is then pulled out of the well and stacked inside the drilling derrick. The derrickman needs a good head for heights for this job. He has to balance on a small platform known as a monkey board, about 90 feet up in this derrick, and guide the lengths of pipe into racks as they're pulled out of the well or tripped out. Once the drill bit has been changed, the derrickman guides all the sections back into position, while the crew on the rig floor replace the thousands of feet of drill pipe into the well. Apart from the actual drilling of the well, the other key feature in rotary drilling is the circulating fluid or mud. This is constantly pumped down the inside of the hollow drill string to the drilling bit, and then back up the space around the drill pipe to the surface. Mud cools, lubricates, and aids the action of the drill bit. It counterbalances any underground pressure in the well, and it brings rock cuttings to the surface. The cuttings are screened out of the mud, which is then recirculated. The cuttings are invaluable indications of the possible presence of hydrocarbons. In the well site laboratory, they're very carefully examined to identify rock types and to check the position of the drill bit as it travels through the rock strata. Mud loggers use sophisticated monitors to detect any traces of gas brought up from the well, while mechanical gas traps extract gas from the circulating mud. British Gas is one of the few exploration companies that has its own extensive laboratory facilities. Rock samples extracted while drilling are sent there for scientific analysis to determine the characteristics of the well using techniques such as laser and scanning electron microscopy. Even after drilling thousands of feet into the subsurface, there is no guarantee of finding any hydrocarbons, and the majority of wells have to be sealed with cement and abandoned. However, before such decisions are made, well logging tests are applied. Technicians working on the drilling rig lower devices called logging tools to the bottom of the borehole. As these tools are reeled slowly back up, they give detailed information such as porosity and fluid content of all the rock formations they pass. But like all other surveys in exploration, well logging requires interpretation and offers no guarantees. In normal circumstances, if there is even a possibility of commercial production, the well is finally tested for the physical flow of fluids to the surface. At this stage, all those involved in the exploration process, like so many explorers throughout history, are poignantly aware that the risks and endurance may be for nothing. There may be no hidden energy in this area. But their reward is to share in the celebration of success when a new gas field is discovered. The quest for gas continues, and many other fields await discovery. But finding them and exploiting their benefits remains a challenge for the skills of the contemporary explorer. British Gas's investment in the future of exploration is an investment in the future of Britain's energy needs, well into the next century.